Bismillahirrahmanirrahim. Welcome. This is a linear system theory, homework 1. We're having a question. A final year undergrad student built a 1 kilogram rocket with 30 Newton thrust and they launched the rocket with 45-degree head angle from the ground. Assume the rocket is point mass with initial speed of 20 meter per second and the thrust is constant during the whole flight. Write the equation of motion for the rocket. Write the equation of motion in Simulink and run the simulation for the 12 seconds. Submit the Simulink model and graph of the heading angle XY coordinates. Indicate the maximum height and the rocket shall achieve and the time to hit the ground. This is the given data. Thrust is equal to 30 Newton. Mass of the rocket is equal to 1 kilogram. Launching angle is 45 degree. Initial speed is equal to 20 meter per second. And the time taken to simulate this model is 12 seconds. The part 1 is the equation of motion for the acceleration, that is by using the Newton law, that is equal to mx double dot is equal to t cos of theta. So acceleration is having a two component, x component, y component. This is the horizontal component. So x dot is equal to t cos theta divided by m. Similarly, the vertical component, the acceleration is given as y double dot t sine theta minus, here is the weight of the body that is acting downward, weight of the, that is the gravitational pull on the rocket. By putting the values of the thrust and the angle, we are having the x component of the acceleration that is equal to 21.213. Similarly, the y component of acceleration comes out to be 11.413. The initial condition for the velocity is given by 12 cos of 45, and similarly for the velocity for the y component we are having 20 sine 45 degrees. So that comes out to be 14.142 meter per second. The height attained by the rocket is given by the Newton law, which is generically equal to half VIT half a t square. Here this is the initial velocity in the vertical component of the initial velocity, and here this is the vertical component of the acceleration. The height attained is equal to 991.44 by calculating. Similarly, we are having the range and the distance covered by this rocket, that is equal to 1697 meter. This is the MATLAB simulating model. We are having here is the acceleration 30 cos d45, this is the x component, 30 sine d45 minus 9.8, so 21.213 x component of the acceleration, and the y component of acceleration comes out to be 11.413. Initial condition, you are having the first integrator, this is second integrator, we are having velocity after this first integrator, this integrate the acceleration, and similarly velocity integrated, and the results comes out to be this displacement. So for the velocity, we are having the initial conditions. The initial conditions comes out to be 20 cos 45 degree, and the y component comes up to 20 sine 45 degrees. All the conditions for the displacement, the initial condition for the displacement are equal to 0. We are having the scope to see the waveform, the plots, and we are having XY graph as well. And here is to see the angle theta, that is equal to tangent inverse y by x. So here this is the block which shows the results in the radian. So here the simulations are performed for 12 seconds, and this shows the angle. This is the angle, the starting from here, and this is the whole time, the 12 seconds simulation time. Similarly, to see the XY plot, we are having the XY plot over here. And this is the XY, this is the red one shows the here this is the time plot. So the red one shows the velocity and the blue one shows the displacement, and the simulations are performed for 12 seconds. Now to see the plot in the XY plot, we are having the XY plot over here. By clicking the XY plot and selecting the X and Y, so on the axis we are having the range, and Y axis we are having the height. So this comes out to be, which is nearly equal to 1696. The range and the height is equal to 991, is equal to 991 meter. So all the results are compiled in the world form right here. This is the Simulink model, and these are the velocity and displacement plots. Similarly, these are the plots of the height and the range of the rocket, and this is the last part shows. So this is the angle, the heading angle of the rocket. With this, this concludes my presentation. Thank you.